Welcome to Chapter 16. We're going to talk about how most materials are mixtures, and then we're going to talk about how chemists classify matter. So a mixture is going to be a combination of two or more substances, and a substance can be either an element or it can be a compound. So most materials are mixtures. This is different from when you have elements that come together to form a new substance. That would be an element forming a compound, and in that case you're forming bonds. But when you form a mixture, no new bonds are formed or broken. So for example, if I took a pitcher full of water, added a cup or two of sugar, and added some Kool-Aid to it, a Kool-Aid packet, and stirred, I would get this beautiful uniform mixture, and it would not have changed the identity of anything. You've still got water there, you've still got sugar there, you've still got the Kool-Aid colors and flavors there. And the compounds haven't changed, but we have formed a mixture. So forming a mixture is not a chemical change, it's a physical change. On Earth, most things are found in mixtures, which can be sorted into the substances that make it up, which are usually compounds, usually not elements, which can be broken down into elements. Now there are some times that there are exceptions to that, like you can find a gold vein and then it is fairly pure gold there. But usually they're in compounds and we have to separate them out into the elements. That's part of the reason why it was so difficult to discover all the elements on the periodic table, is a lot of them were only found in compounds. So when we have a mixture, we need to be able to separate it by a physical means. An example of physical means would be distillation. So if you have salt water and you want to get the water back out of the salt water, you can boil the water and separate it off. You can even do this with two liquids. If I had two liquids that had different boiling points, I could heat it up just to the lower boiling point, boil off the lower boiling substance, and retain the higher boiling substance below. And I might have to do that several times if they're close in boiling points, but I could eventually separate these two liquids based on their boiling points. Filtration is another example. If I had filter paper and I had some sand that's in water, I could pour the sand water on top. The sand would stay on the filter and the water would go down below the paper. Chemists like to classify matter, and one of the ways we classify it is by how it's mixed. So if you have just an element or just a compound, we call that pure. And if something else is mixed in, we call that impure. And the impure ones have various classifications. So if they mix and they are uniform in how they look, so like Kool-Aid is a great example. You stir it up really well, you're not going to have like a patch of red at one part in your pitcher. You're not going to have a clump of sugar at another part in your pitcher. So that's uniform throughout. That would be a homogeneous mixture. Remember, homo is same. So it's a mixture that looks the same throughout. If you have a heterogeneous mixture, you can see differences. So hetero means different. If I were to take chunky peanut butter, you can see the chunks of peanut mixed in with the cream. So there's differences there. If I take seashells and sand, you can see the shells, you can see the sand. There's differences there. And even the sand itself, you can see color differences. So that would be heterogeneous. Vinegar, salad dressing, oil and vinegar, you've usually got your water level and you've got your oil level, and you can tell the difference. Those are all heterogeneous. If you have a solution, then it's a homogeneous mixture where all the components are in the same phase. So you can actually have a solution of solids. You can mix together several metals, and that's a solution. You can have a solution of just liquids, where you mix them together and they mix well. That's going to be a solution. When they mix, they're all gas, all liquid, or all solid. If you spin them in a centrifuge, they stay mixed. But if I were to take a solution that had two phases present and spin it in a centrifuge, it would separate out. So for example, if I had some muddy water and I spun it, the dirt would go to the bottom because it weighs so much more as a solid, has a greater density. If I took butter and spun that, it would separate out because butter has a liquid component and a solid component. The liquid is water and the solid is proteins and fats. And if you've ever melted butter in the microwave, you'll notice it starts to separate out and you get areas of solid and areas of liquid going on. So to determine what you have, you can go through this question sheet here. First question you'll ask is, does it have uniform properties? If it does, you go on to the next question. If it doesn't, you've got a heterogeneous mixture. You can see differences in what's going on there. If it was uniform throughout, then the next question you ask is, does it have a fixed composition? In other words, is it made of all the same thing? And if it's not, then you have a solution, something that's mixed uniformly but made of more than one thing. So this would be your Kool-Aid sort of an example. If it had a fixed composition, then you ask, can I break it down into something smaller that is individual? If you can't, you're dealing with a pure element. It's only one thing. If you break that down any further, you just get protons, neutrons, and electrons, and that's the case for all matter. So that wouldn't count. So you gotta, if you can only break it down to the element level, you're there. But if you can break it down further, like water, we can break that down into oxygen and hydrogen, then you're dealing with a compound, which is a combination of elements bonded together. So let's say we have a matter. It'll be a liquid, a solid, or a gas. And I can use physical methods to prepare your mixtures or to separate them. So if I've got a mixture and it's got a variable composition, it can be a homogeneous mixture, one that's spread out beautifully, a heterogeneous mixture, which is one that you can see different areas, it's not really mixed together fully, a colloid, which is going to have clouds or smokes or aerosols or emulsions. Colloid's one of the big tip-offs for a colloid is you can't see through it to the other side, even though it looks uniform. So milk is a colloid. I know they say it's homogenized, but it's a colloid. So if you try to shine a flashlight through your milk, you don't generally get light out the other side because the milk fat has been suspended throughout that milk, and so have the proteins. If you take your non-fat milk, you might be able to see it a little bit because you have less in that cloud there. The composite materials are things like rock, wood, yeast. These are dynamite. These are things that you can see differences in them, but they're kind of put together there so that you can see what's going on. And then we have our pure substances. These have a constant composition, so we have the elements on the periodic table. That would be pure. We have binary compounds, where you've got two types of elements combined in some ratios. You have your polyelemental compounds. These have more than two types of elements combined. And then your types of pure substances can be categorized as a network of covalent materials, or molecular substances, or polymers or plastics. Metallic elements, which are your metallic bonding we were talking about. Alloys, which are going to be a mix of metals with a few other things thrown in. They are often built for things like strength. So your ring is an alloy, because if it were pure metal, it would be too soft. Your glasses, your simple ionic salts, molecular and complex salts, your minerals. These are all pure substances. And they think they might be able to have atomic ions and molecular and complex ions, but these are more hypothesized than proven. So here we have some pictures of matter, and you could decide which of those classifications does it go into, not the latter ones, but the earlier ones. Is it a mixture? Is it pure? Is it a compound? Is it a homogeneous or a heterogeneous mixture? So A, you'll notice there's dots there. They're all the same color, all the same size. That means it's all one element. So this would be a pure substance, and it would be an element. B, you've got some that have different colors. So we've got more than one element going on, and there's two different types. There's the pink one with two blues, and then there's the green ones down here at the bottom. So this is a mixture. It's got two different things in it, two different kinds of, maybe a compound in the green, maybe an element. And so that is a mixture, and it's heterogeneous because notice they're not mixing evenly. On C, we have blue and red, so two types of elements, and they are dispersed fairly evenly, so this would be a homogeneous mixture of two elements. On D, we have two dots next to each other. Those two dots each represent an element. There's only that substance in there, so this is a pure substance, but it's a compound. So you kind of see how I did A through D. See if you can do E through P and figure out what they are. And if you have questions, be sure to ask me.